Okay. Um, we'll go on. Okay, I'm just going to tack number 6 on. 4 and 5 are on another video. I realized that I had a different page and then I had added a problem here. So I just want to tack on this number 6. Now this is an exponential equation. And this would be exponential decay because the value here, the growth value, the base value here is between 0 and 1. It's smaller than 1, bigger than 0. And when that is the case, we have exponential decay. And this equation is actually being shifted. When it's shifted 2 units left, then we're going to take the whatever this x is, we're going to add 2 to the exponent there. And when it's shifted 4 units up, we're going to add 4 to this amount, the constant here at the end. Okay, the 2 is not changing, the 1/2 is not changing. We're going to add 2, so 2 minus 1 is positive 1. So x minus 1 plus 2 is x plus 1. Negative 1 plus 2 is positive 1. And then 4 units up, negative 3 plus 4. This was plus 2. Negative 3 plus 4 is plus 1. And that's all there is to it on number 6. That's the new equation. So it's just a transformation problem more than exponential decay problem. All right. Well, let's put number 7 on here. For the general exponential formula, y equals a times b to the x minus, please note that that's a minus, h plus k. Explain how we know we have the exponential growth, or decay. Also, describe a technique for finding the y-intercept. Okay, this is just to help you kind of review and what you need to do. You may have a set of matching problems where you'll have to identify the y-intercepts on all of them, and you're also going to have to identify if they're exponential growth or decay. All right, well, growth, exponential growth, b is greater than 1. So the number we're raising to the power is a number bigger than 1, like 1.1, 3, 2.718. Anything bigger than 1 would represent exponential growth. So an example would be like y equals, let me put 1/2 out here. It doesn't matter what this is. I'm just going to put a 1/2 out here. Equals 2.1 times x to the x minus 2 plus 7, whatever. The fact that this is bigger than 1 means this is growth, exponential growth. Now, decay would be when b is bigger than 1, whoops, but it's bigger than 0. Sorry. b is less than 1. Let's turn these around, please. b is less than 1 and b is greater than 0. That is exponential decay. So that would be something like y equals, I'll put a 3 out here, something bigger, but it doesn't matter, times 1/2 to the power of x plus 3 minus 4. Now I have 2 equations here I'm going to mess around with here a little bit. To find the y-intercept, the y-intercept happens, the y-intercept is found when x is equal to 0. So, this first one, y is going to equal, this is the y-intercept, 1/2 times 2.1 to the 0 minus 2 power plus 7. Alright, let's take 1 divided by 2 times 2.1 to the power of negative 2. Bring it down and go plus 7. And I get 7, so this is approximately 7.11. So just remember, all I did was put a 0 in for x. This is the y-intercept. On this one, 3 times 1/2 to the power of 0 plus 3 minus 4. The y-intercept, so let's take 3 times 1/2 to the power of 3, and then go, when I hit the arrow, it takes it out of the exponent and brings it down to the normal place, minus 4, and I get negative 3.625. These are the y-intercepts. These are where the graphs are going to cross the y-axis for that equation and that equation. So that's all there is to finding the y-intercept. How do we find the y-intercept? We set x equal to 0 and do the calculation. Okay? And exponential growth, the base here is bigger than 1. Exponential decay, the base here is between 0 and 1. It's less than 1, bigger than 0. Alright, let's get this problem. Oh, alright, I didn't realize I actually added a couple examples. I didn't look ahead enough here. Oh well, it gives us a little more extra practice, doesn't it? So, exponential growth or decay, we're looking here. If you'd answered decay, you are correct. And if we plug in 0 for x, we'll have the y-intercept equals 3 times 1/4 to the power of 0 minus 1 plus 2. So that's 3 times 1/4 to the negative first plus 2. And I think if you do that, you can put that in your calculator, but when I take 1/4 to the negative first, that's like 4 over 1 to the first, which is 4. 3 times 4 is 12, plus 2 is 14. You check me on that. Make sure I did that right. But I think the y-intercept for this one is 14. And part B, I'm looking at only for growth and decay. I'm looking only at this, at the 3, and I'm saying that is exponential growth. And then the y-intercept is 0.8 times 3 to the power of 0 minus 7, which is 0.8, and anything to the power of 0 is 1 minus 7, which is 0.8 minus 7. I think if you calculate that, you're going to get negative 6.2. And again, you can check me on that one. Alright, so that was numbers 6 and 7. I'm going to do another video for the next ones.